As is obvious from the title and thumbnail, we're going to be discussing a mathematical model of when it makes sense to concede in MTG Arena while climbing the ladder. But before we get started, I want to put out a disclaimer. This is a card game, and there are plenty of reasons to concede, or not to concede, that fall outside the scope of this video. And I know that in general, conceding can be a pretty divisive topic, so I'm not going to advocate for you, the viewer, to go out and start conceding like a robot. I just wanted to answer when it made sense from a perfectly performance-minded perspective. Okay, with that out of the way, let's get into the analysis. The first question you might be asking yourself is, hey, doesn't conceding make me lose? And you'd be right, conceding does make you lose, but it does something that's equally important. It saves you time. And as we all know, time equals money. And in this case, by money, I mean excess wins. If you have a positive win rate, every game you play takes you another step along this generally upward sloping roller coaster, which means that we want to get you playing as many games as possible in the time you have to play. But exactly how much is each game worth? In Magic the Gathering Arena, in ranked mode, you get 1 point for a win, and you lose 1 point for a loss. So we can't look purely at your win rate to determine how many points you get per game. For example, say you have a 55% win rate, meaning that in 100 games, you'll win 55 and lose 45, leaving you with a net 10 points and an average of 0.1 points per game. In general, the formula for excess wins is thus your win rate minus your loss rate, which is just equal to 1 minus your win rate. If we simplify this, our total formula is our excess wins per game is equal to 2W minus 1, where W is your win rate out of 1, a spectrum from 0 to 1, as opposed from 0 to 100. Okay, so now we need to calculate how much your time is worth, from the perspective of Magic the Gathering. For this, we're going to need to know the average length of the games you play on Ranked Ladder. Since we calculated the excess wins you get per game, we can find the excess wins you get per minute by simply dividing that value by the average length of your games. Okay, so now that we know how much your time is worth, we can calculate how much you gain from conceding by simply multiplying by the amount of time that you expect the rest of the game to take, were you to actually play it out. Of course, you'll never know this for sure in the middle of a match, but we will just assume that you can make an educated guess, and we'll continue with that value in mind. We'll see how differences in this value can change your decision making later on in the video. Obviously, conceding also comes with some downsides, but it might not be as bad as you would think initially. When you concede, you're probably already very likely to lose the match, so it is not fair to say that the cost is equal to the entire point. Instead, we need to look at two possible hypotheticals, one where you finish the match normally, and one where you concede, and calculate your expected points in each case. For conceding, you'll clearly lose an entire point 100% of the time. However, if you were to play on, the expected number of points you receive depends on the likelihood you are to win the game. Again, this number depends on an educated guess. The cost of conceding, then, is the difference between our two hypotheticals. Once we do that algebra, it turns out to be exactly equal to 2 times the chance of your winning the current game. This makes sense from an intuitive perspective, because we are punished for losing exactly as much as we are rewarded for winning, which creates a doubling effect for our costs. Okay, now that we have the costs and the benefits for conceding, we can put it together into one formula for the total expected point change for an individual concession. As you can see, this depends on 4 different variables, which may seem unwieldy at first, but 2 of these variables can actually be reduced to a constant. Since your average win rate and game length won't change over the course of an individual game, we can simplify the equation to this, where m is the number of excess wins we expect per minute, which we calculated earlier and can treat as a constant. Now that our function consists of only 2 variables, we can actually model it in 3D space. Okay, so this is what the graph looks like in 3 dimensions. The x-axis represents your expected chance to win the current game, from 0 to 1. The y-axis represents how much time you expect to save, from 0 to 15 minutes, and the z-axis represents the amount of points you stand to gain from conceding, from 0 to 1. Of course, these will vary based on your win rate and game length. And the initial values I configured are based on Untapped GG's data for the best deck in standard for Platinum. But as you can see, there are sliders to the left to edit these values, and I'll be putting these graphs in the description so you can play around with them yourselves. An important thing to note is that if the value of z is ever positive, it makes sense mathematically to concede, so we only ever really need to look at the plane, where z equals 0. And it makes it a little easier to think about because it's only in 2 dimensions. So let's switch over to that graph now. This is what the graph looks like in 2 dimensions. You can think of this as taking a slice of the 3-dimensional shape we saw earlier. In this graph, anywhere shaded in blue represents a point where it makes sense to concede. For example, if you think you only have a 5% chance of winning the game, you only need to save around 3 minutes for that to be worth it. On the other hand, if you think you only have a 1% chance of winning the game, you only need to save around 30 seconds. And if we zoom out, if you think you can save 30 minutes by conceding, you should concede even if you have a 50% chance of winning the game, which really puts into perspective how important time is in this context. Of course, all of these values are going to be educated guesses, but I still think this graph can be helpful to visualize the decision-making process, and can let you think about whether or not you're conceding too much or too little in your games. That's all for this video. Please let me know in the comments if you have any other questions you'd like me to take a look at, and subscribe for more. Cheers!